The chisel plow. The combine has been through. The field is covered in stalks and cob fragments and the compacted tire tracks of a harvest that just put several 100,000 pounds of machinery through the same rows repeatedly. The chisel plow goes in first. It's a primary tillage tool, a wide frame pulled by a tractor, carrying multiple shanks that plunge into the soil at angles between 8 and 14 inches deep. Unlike a moldboard plow, which flips the entire soil profile upside down, the chisel plow fractures. It breaks up the compacted layers without fully inverting the topsoil, driving tines downward through the soil and leaving fissures, channels for air, water, and roots to move through the following year. Corn requires more aggressive tillage than most crops. The root systems are massive, the stalks are woody and decompose slowly, and after a full season, the ground beneath heavy machinery is compacted in ways that will suppress next year's germination if left unaddressed. The chisel plow solves this. It disrupts compaction. It breaks up residue. It creates a roughened, open surface that weathers through winter in a way that smooth, undisturbed soil does not. A large chisel plow working 30 feet wide covers roughly 150 to 200 acres per day. On 10,000 acres, this takes the better part of 2 weeks in fall, running every day that the ground isn't frozen and isn't too wet to support the tractor. Around 50 to 70% of the original crop residue remains on the surface after chiseling. That residue is not waste. It protects the soil from wind and water erosion through winter, and by spring it has begun decomposing into organic matter that feeds the next crop. The chisel plow is the first machine on the field after harvest. Nothing that comes after it works as well without it. The field cultivator. The ground has thawed and dried enough to work. The chisel plow left the field rough. Clods, ridges, uneven surface, partially incorporated residue. Before any seed goes in, that surface has to be finished. The field cultivator is secondary tillage. Where the chisel plow works deep and rough, the field cultivator works shallow and precise, typically 2 to 4 inches, smoothing the seedbed, breaking up clods, and leveling the surface to create a uniform environment for germination. It's a wide, flat machine, 40 to 60 feet across on a large operation, pulled at 6 to 8 miles per hour, its C-shaped shanks running just below the surface, followed by rolling baskets or harrows that crumble and level what the shanks disturb. The goal is a firm, fine-textured seedbed with consistent moisture contact for every seed that enters it. Timing is everything with secondary tillage. Work the ground too early when it's still wet, and the cultivator smears and compacts rather than loosens, a condition called sidewall compaction that restricts root growth for the entire season. Wait too long and the window to plant closes. Farmers in the Corn Belt watch soil temperature and moisture forecasts the way coastal sailors watch weather, because the difference between ideal and marginal field conditions can be a matter of days. A well-finished seedbed is invisible from the road. What it represents is months of root growth that won't be fighting through clods or inconsistent soil density. It is the last preparation before the seed enters the ground. The anhydrous ammonia applicator. Corn is the most nitrogen-hungry crop in large-scale American agriculture. A 200 bushel per acre corn yield removes roughly 160 to 200 pounds of nitrogen from the soil per acre. That nitrogen has to come from somewhere. Anhydrous ammonia is the most concentrated nitrogen fertilizer that exists, 82% nitrogen by weight, compared to roughly 46% for dry urea. It is injected directly into the soil as a liquid under pressure, where it reacts with soil moisture and converts to ammonium, the form roots can use. Nothing delivers more nitrogen per gallon per dollar. It is also one of the most dangerous materials handled routinely in agriculture. Anhydrous ammonia is a gas at ambient temperature and pressure, stored and transported as a pressurized liquid. If it contacts skin or eyes, it causes severe chemical burns. It has a boiling point of minus 28 degrees Fahrenheit. A tank leak is a genuine emergency. Every applicator carries a bucket of water on the toolbar for exactly this reason, and every operator works in PPE that covers exposed skin and eyes. The applicator itself is a toolbar pulled by a tractor carrying a pressurized tank of anhydrous ammonia and a set of injection knives that open the soil, release the ammonia at 6 to 8 inches depth, and seal the slot behind them to prevent gas escape. GPS guidance ensures the injection paths are consistent and that no section of field gets double applied. It has to be applied when soil temperature at 4-inch depth is at or below 50 degrees Fahrenheit, cold enough that soil microbiology is slow, which prevents the ammonia from converting to nitrate too quickly and leaching away before the crop can use it. Fall or very early spring. Too warm, and the investment walks off the field in runoff before the corn emerges. On a large field, the anhydrous applicator makes a single pass. Everything planted into that soil will draw from the nitrogen band that pass left behind. The corn planter. This is the most precise machine on the farm. Everything the chisel plow and field cultivator did was preparation. Everything the sprayer and combine do comes after. The planter is the moment of commitment. The machine that takes 30,000 individual seeds per acre and places each one at exactly the right depth, in exactly the right spacing, at exactly the right downforce to achieve contact with moisture within the exact days of the planting window that will determine yield potential for the entire season. A modern corn planter runs 16 to 24 rows simultaneously, each row unit operating independently. Each unit has a disc opener that cuts a precise furrow, a seed meter that singulates, isolates, and releases exactly one seed at a time, a delivery system that places that seed at the bottom of the furrow, closing wheels that press soil around it, and a downforce system that adjusts automatically based on soil resistance to ensure consistent seeding depth across varying soil types. The population is around 32,000 seeds per acre for most commercial corn belt fields. At 30-inch row spacing with 24-row planter, that's one seed every 6.5 inches, placed at 1.5 to 2 inches depth, consistently across every acre of the field. Variable rate seeding adjusts population automatically based based on a prescription map, high-yielding soil zones get higher populations, marginal areas get fewer, squeezing additional return from every acre. Planting speed matters because the planting window is short. 5 to 7 days is a typical optimum window for a given field and variety combination, and getting the entire operation planted within that window is the difference between uniform emergence and a crop where different areas of the field are at different growth stages from day one. The John Deere ExactEmerge delivers accurate singulation and spacing at up to 10 miles per hour, double the speed of conventional planters, which means a 2,500-acre farm can be planted in 6 days instead of 10. A misplanted field, seeds too shallow, too deep, too crowded, or in poorly prepared soil, cannot be fixed. The crop carries those errors from emergence through harvest. The sprayer, pre-emergent pass. Before the corn breaks the soil surface, the weeds are already germinating. Weed control is not optional in large-scale corn production. Corn competes poorly with weeds in its early stages, and a field with significant weed pressure in the first 4 to 6 weeks of growth loses yield. Research consistently shows that weed competition during the first month can reduce yield by 10 to 50% depending on weed species and density. The problem doesn't fix itself. Weeds also set seed, compounding the problem in future seasons. The sprayer's first pass is pre-emergent, applied to the soil after planting, but before the crop emerges. The herbicide in the tank doesn't kill existing weeds. It creates a chemical barrier in the top inch of soil that kills weed seeds as they germinate. It gives the corn several weeks of clean growth while the weed population is suppressed. A self-propelled high-clearance sprayer works at boom widths of 90 to 120 feet and speeds of 15 to 20 miles per hour, covering 500 to 1,000 acres per day. Section control, automatic shutoff of boom sections when the GPS detects overlap at field edges or previously sprayed areas, prevents double application, which wastes chemical, harms the crop, and leaves residues in the soil above legal limits. The chemistry in the tank is precisely measured and calibrated to the soil type, organic matter content, and weed pressure of each field. Too little, and the barrier fails. Too much and residues persist into the next crop. The application rate in gallons per acre, the droplet size from each nozzle, and the boom height above the soil are all variables that change the effectiveness of what gets applied. The sprayer makes this look simple. It isn't. The sprayer, post-emergent pass. The pre-emergent barrier doesn't last indefinitely. By the time corn reaches the V3 or V4 growth stage, 3 or 4 visible leaf collars, the chemical barrier in the soil has begun to break down, and a new generation of weeds is emerging. A second pass is needed. The post-emergent pass targets emerged weeds directly. The chemistry changes, contact and systemic herbicides that kill existing weed plants rather than preventing germination. The sprayer makes the same wide passes, but now the corn is in the ground and growing, and the operator is moving through a crop that exists. At V4, corn is roughly 12 to 18 inches tall. The sprayer's high clearance design, large diameter tires, elevated frame, passes over the rows without crushing the crop. The boom rides above the canopy. Nozzles are calibrated for droplet size and coverage that reaches the weeds at the base of the canopy without excessive drift. Timing matters here as it does with everything. Post-emergent herbicides are most effective when applied to small, actively growing weeds. Large, established weeds require higher rates and are less reliably controlled. Waiting too long means weeds that have already competed with the crop for light and nutrients for 2 or 3 weeks. Some operations are now beginning to use camera-equipped sprayers with machine vision, systems that identify weeds from corn plants in real time, and pulse individual nozzles on and off as they pass over weed plants versus crop. John Deere's See and Spray system has documented herbicide use reductions of over 60% in test conditions compared to broadcast application. The economics haven't reached the point of universal adoption, but the direction is clear. The sprayer's second pass closes the weed control window. From V6 onward, the corn canopy will shade the soil enough to suppress further weed germination on its own. The high clearance applicator, side dress nitrogen. The pre-plant anhydrous ammonia delivered the base nitrogen, but 10,000 acres of corn in a year with significant spring rainfall presents a problem. Some of that nitrogen has leached below the root zone, or denitrified, converted by soil bacteria into gas, and lost to the atmosphere, before the crop was large enough to use it. Side dressing is the solution. A second nitrogen application, made in season after the crop is established, replaces what was lost and supplements what remains. It's applied when the corn is at V4 to V6, tall enough to confirm it's growing well, young enough that the root system can still use the application efficiently before peak nitrogen demand hits around tasseling. The machine is a high-clearance applicator, a modified self-propelled unit with tall clearance, narrow-track tires that fit between the 30-inch rows, and an injection toolbar that runs anhydrous ammonia or liquid UAN solution between the rows at the same depth as the pre-plant application. It travels between the rows without damaging the crop standing above it. At V6, corn is 18 to 24 inches tall. The applicator clears it without contact. By V8, that window is closing. By V10, it's gone. The decision to side dress and how much to apply is one of the most consequential economic decisions of the season. Corn's peak nitrogen demand occurs from a V10 through tasseling and grain fill. Roughly 6 to 8 weeks after side dressing would be applied. Underapply and yield potential is permanently reduced. Overapply and the excess becomes an environmental liability and a wasted input cost. Soil testing, weather history, and yield maps from previous seasons all feed into that calculation. The combine harvester. Fall returns. The corn has been in the field for 5 months. It has reached maximum kernel fill. Moisture has dropped toward 20 to 25% as the plant approaches dry down, and the stalks that were green in July are now dry and brown. The harvest window is open. The combine is the machine that ends the season and begins the accounting. It is also the only machine on this list that has to be right about everything at once. The corn head at the front strips ears from stalks at high speed, pulling them into the feeder house. The threshing system, on modern machines a pair of large diameter rotors running the length of the machine, breaks the kernels from the cob without breaking the kernels themselves. Broken kernels grade as damaged and receive a market discount. The cleaning shoe uses airflow and sieves to separate kernels from chaff, cob fragments, and other material. Clean grain goes to the tank, residue goes to the chopper and spreader, distributed back across the field as the machine moves forward. Loss matters. A single kernel missed per square foot of field equals roughly 1 bushel per acre of lost yield. On 10,000 acres at a market price of $4.50 per bushel, 1 bushel per acre of additional loss is $45,000 left in the field. The combine's settings, rotor speed, concave clearance, fan speed, sieve opening, are adjusted continuously based on crop condition, moisture, and yield to minimize that loss. Modern combines are connected. Yield maps are built pass by pass as the machine moves through the field, recording bushels per acre at every GPS coordinate. Those maps will be the first document a farmer opens next spring when deciding how to manage inputs. Every pass the combine makes is also a data collection pass, building the agronomic record that will shape decisions for the next season. The combine doesn't close the loop on a cornfield. It hands the information to the farmer, and the farmer, who has already been watching the next year's input prices and reading the forecast for fall tillage conditions, begins planning the first machine pass of the following season before the last load is in the bin. That is the sequence. A chisel plow in October breaking compaction and starting residue decomposition. A field cultivator in April finishing what the chisel left rough. An anhydrous ammonia applicator injecting nitrogen into cold soil before anything germinates. A corn planter placing 32,000 seeds per acre at exact spacing and depth in a window measured in days. A sprayer making 2 passes, one before the crop emerges, one after, holding weeds below the threshold where they reduce yield. A high clearance applicator replacing nitrogen that spring rains stole before the crop could use it. And a combine in October that converts 5 months of machine work into bushels. 8 machines, 1 field, 1 season. The corn doesn't grow because of the rain. It grows because every machine in this chain did its job at exactly the right time.